Hi everyone, I'm Harshit, and today we are gonna build Claude. You heard me right. As you all know, Claude is one of the most powerful AI assistants out there. Today, we are gonna try and rebuild it ourselves. Yes, with a lot of questionable decisions because we don't have access to Anthropic's data, nor their code, and definitely not to their GPUs. But we do have access to enough information that lets us know how Claude works. Let us see if we could put those things together and try to rebuild our version of Claude. See you guys there. Alright. Before I start building anything, I need to understand what makes Claude different from other AI assistants. If I don't understand the architecture of it, there is no way I can rebuild it. I started researching how Claude works, how Anthropic trained it, and this is where things started getting interesting. Anthropic has this concept called constitutional AI. Instead of only relying on humans to correct the model, they actually make the AI critique and revise its own responses using a set of principles. And this idea becomes a huge part of what we are building later. And then I found Claude isn't just answering questions, it constantly being guided by a set of rules and principles called constitutions. Basically, a built-in system that pushes the model to be helpful, honest, and harmless. So naturally, I'm stealing the idea. So, and next I found this paper. And the more I read these papers, the more I realize something. Claude isn't just one giant AI model. It is a system. A AI model with memory, retrieval, self-critic, and safety layers, which is actually good news because it means I don't need Anthropic's model to rebuild the architecture. Now that I had a rough understanding of how Claude works, I needed something to act as the foundation. And let's be realistic, Claude is trained on an enormous amount of data using the infrastructure which most developers will never have access to. For that, I went back to researching. Now, at this point, Quen is just a language model. It can generate text, answer questions, and hold conversation. But it doesn't have any of the Claude inspired systems I want. No constitutional AI, no retrieval pipeline, no reasoning architecture, no self critic loop. And so the next step was turning this simple language model into something much more interesting. Now, before I build anything, I need the tools. Claude, GPT, Gemini, and pretty much every modern AI assistant are built on top of something called the transform architecture. So the first thing I'm doing is installing the libraries and let me work with transform models directly inside Google Colab. And ensure that your runtime is connected to T4 GPU. That would be quite faster. So I'll run this cell. Just wait for the installation to get completed. With the libraries installed, let us import everything we need. The transformer library gives access to modern language models. PyTorch handles all the neural network computations happening behind the scenes. NumPy helps with numerical operations. And sentence transformer is going to be important later when we start building retrieval and memory systems. At this point, we are not building Claude yet. We are just setting up the foundation. And now let us start writing the code. First, I'll set up the model's name. Model name equals within double quotes Quen slash Quen 2.5 hyphen 0.5b hyphen instruct. Cool. After reaching different open source option, I decided to go with Quen 2.5. Just like Claude, Quen is also built on transform architecture. It is lightweight, capable, and most importantly, it can run inside Google Colab without needing a data center. And now tokenizer equals auto tokenizer. It's already suggesting here. Tokenizer dot from retrained. Could not these things for now. Okay. So before the model can understand the language, text has to be converted into tokens. A tokenizer is responsible for breaking human language into pieces that the model can process. Think of it as the translator between us and the AI. And here we are loading the actual language model. This is the closest thing our project has to a brain. But even though the model is now loaded, we are still nowhere close to Claude. First, let us load the model. Right now, it's just a transformer capable of generating text. Everything that makes Claude feel intelligent still needs to be built around it. It is around 988 MB. Here we go. It's done. And now, the next thing I need is an embedding model. While the language model generates text, the embedding helps us understand the meaning. Later on, this is what will allow us to search for relevant information, retrieve memories, and find context that is related to user's question. Let's run this. Done. So now we have the foundation, a language model that can generate text, an embedding model that can understand the meaning. The next step is building the systems around them that make Claude feel like Claude. Alright, so now let us start building the Claude specific systems. One of the things that I kept seeing while researching Claude was something called constitutional AI. Instead of relying entirely on human feedback, Claude is guided by a set of principles that influence how it responds. Now, obviously, I'm not recreating Anthropic's entire training process, but I can recreate the idea. So, I'm creating a small constitution that my assistant will use as a set of rules when generating a response. So, now I'll just run the cell. So, we now have the constitution. And now, with the constitution defined, I also want a simple safety layer. Before any request reaches the model, it will first pass through a guardrail system that checks for obviously dangerous instruction. So here I have defined something like a block patterns, which are simple patterns for guardrail. Think of it as the first checkpoint in the pipeline. I'll run it. Cool. And now the next thing Claude is known for is its ability to handle large amount of context. Now that I can't recreate a 2 lakh token context window in a weekend project, but I can recreate the idea. So I'm building a memory manager that stores previous conversation turns and keeps the most relevant context available to the model. So here we have the class called adaptive context memory. It is first getting initialized with a maximum number of tokens, and it will be storing the turns and truncating to the context. And then we have get message function, which will be retrieving the most recent context. At this point, the AI can generate text, understand the meaning, follow a constitution, and also remember the text. So now it needs knowledge. One problem with language models is that they only know what they learned during training. Claude solves this using things like retrieval systems and external context. So for my version, I'm creating a small knowledge base that the AI can search whenever it needs information. Think of this as giving the model access to notes instead of forcing it to memorize everything. Now I'm converting every piece of knowledge into embeddings. Hope you remember the embedding model we loaded earlier. This is where it becomes useful. Instead of storing information as plain text, we are converting it into vectors and capture the meaning. That allows the AI to search semantically instead of matching exact words. And now comes the actual retrieval system. Whenever a user asks a question, I will convert that question into an embedding and compare it against everything in the knowledge base. Whichever piece of knowledge is the most relevant gets sent to the model as additional context. This is basically a miniature version of retrieval-augmented generation, or you call RAG. One thing I found interesting while researching Claude was that Anthropic offers different model variants: Haiku, Sonnet, and Opus. Each one is optimized for different balance of speed and intelligence. So I decided to recreate the idea here. And here we have different model profiles and their specifications. Now let's have a closer look. Haiku is lightweight profile. It is known for fast responses, less computation, low latency. And next we have Sonnet. Sonnet is the balanced profile. It is known for good reasoning and it is especially known for its speed. This is one I will probably use most often. And the last, Opus. And finally, the most expensive profile. More tokens and more reasoning, and of course, more detailed responses. And at this point, the individual pieces are starting to come together. But I still need a way to decide how the system should respond to different types of questions. And that's where things get interesting. One thing I didn't want was for every single message to go through the entire pipeline. Because let's be honest, if someone says hi, I don't need retrieval, I don't need reasoning, and I definitely don't need a self critic loop. So I built something called an intent router. Its job is simple: look at the user's message and decide how much thinking is actually required. So here we have the prompt. Instead of hard coding the rules, I am actually asking the model to classify the request itself. Is this a casual conversation or does it require knowledge and reasoning? Depending on the answer, the request gets routed on a completely different path. And now, when we go here, in my case, there are only two routes: a lightweight chat path and a deeper reasoning path. Simple, but surprisingly effective. And now, we are getting somewhere. The AI can now decide how much effort it should spend answering the question, but we still haven't actually generated responses yet. And now let's go slightly upwards here. This function is the heart of the system, base LLM call. Every time the AI model needs to think, classify, critic, revise, or answer something, it eventually comes through here. This is the point where all our architecture finally talks to the language model. So now if we have a closer look, this part, first step is converting the conversation into a format the model understands. Remember the tokenizer? This is where it goes to work. And now if you have a look at the output, this is the moment the model actually generates text. Everything we have built so far has been preparing for this one step. And before I let the AI answer questions, I wanted to give it something Claude is famous for: the ability to think before it speaks. And this part is doing that. The running reasons planner. And basically, the reasoning planner works like it takes the user's question, breaks it into smaller steps, and gives the model a direction before the final answer is generated. At this point, I had a model, a memory system, retrieval, reasoning, and safety. But none of these pieces were connected together yet. So now it is the time to build the actual Claude pipeline. And now here we come to the function. This is the brain of the entire project. Every user message eventually ends up here. And from this point onwards, the system decides exactly how the message should be processed. Now let's have a closer look. The first if block. The very first thing I do is run a constitutional safety check. If the request violates the rules I defined earlier, the pipeline stops immediately. And next, the intent. This is the routing layer. The AI decides whether this is a simple conversation or something that requires a deeper reasoning. And now let's go to the if block, the first one. If it's just a casual conversation, we take the first path. No retrieval, no planning, and no critic loop. Just a quick response. But in case if the question requires an actual knowledge, we activate the full pipeline. First, we retrieve the relevant information from our knowledge base, and that is being done by retrieve data equal retrieve knowledge from the question. And next comes this part, the reason planning. Then the AI generates a reasoning planning describing how it intends to approach the problem. And our next part is the draft answer. Here we go. Using both the retrieved information and the reasoning plan, the model produces its first draft answer. And now comes the critic messages. Instead of immediately returning the answer, the AI critiques itself. It checks whether the response follows the principle defined in the Constitution. And now the final answer. And finally, using its own feedback, it rewrites the response and produces a cleaner final answer. So instead of generate and return, the process becomes generate, critic, improve, and return, which is one of the core ideas behind constitutional AI. And with everything connected together, there is only one thing left to do: run it. And now to check if the model is actually working, I have a small run command here. I just run. Cell is already running, so I'll just stop it and run once again. Here we have the different models, so I'll select, say, model Opus, and now I'll say, hey, let's see. So if you have a closer look, it is skipping the reasoning part. And already we have defined like whether, based on the user's question, whether it has to undergo the reasoning pipeline entirely or just skip it and move forward. So it just worked the way we intended it to. Hello, how can I assist you today? How are you? As a Claude, I don't have feelings, but I'm always ready to engage. Okay, it's working good. And now let's try some math over it. What is, say, 8 times or 1 or 191, 192, whatever. Okay, it has calculated the value 8 to 16. Okay, it's perfect, good. And now let's give it some question that might trigger any of these. What makes you, or whatever, like what makes Claude function really well, and how is Claude built? Oops, too many mistakes. It takes quite a long time. And here we got the response. So it has undergone the retrieved vector context, also the CAI, and then the final output comes like this. Claude functions exceptionally well because of its unique blend of advanced AI techniques and profound understanding, and blah blah blah. The architecture is also given. And in summary, Claude combines advanced AI techniques with deep understanding of natural. Great. So our model is actually functioning the way we wanted it to. That's actually great. And honestly, that's kind of insane. A few hours ago, this was just a small open source model. And now it's running a mini Claude style architecture with reasoning, retrieval, self critic, and multiple execution paths. I would call that a pure success. And with that, the mini Claude is complete. It might not be the real Claude, but it does capture many of the ideas that make Claude so interesting in the first place. If you enjoy this build, make sure you subscribe and let me know what AI system I should try rebuilding next. I'll see you in the next one. Bye.